the areas of two sectors of two different circles are equal. Is it necessary that their corresponding arc lengths are equal, and why? So what we have here is two circles. Their areas of the sectors are equal. So we have, say, this big area over here. The area here remains the same, just that it's in a small space in some manner, right? So we'll call this as, say, x and y and so on and so forth. So the radius is x over here, and say here it's y, and we'll call this angle as A, this angle as B. Here the main thing here is what? The angles are the same. Sorry, not the angles, areas are the same. So this part of the circle is equal to this part of the circle. Something like this. Make sense? Okay. And now we are looking at finding if the lengths are equal. I hope you guys know the answer. We'll call this as L1 and that as L2. So the answer is no. Right? Okay, let us show that it is not. So we have been given the following thing, that the areas of the sectors are equal. Areas of the sectors are equal for the given triangles. So we need to assume few things before we start working on it. So what is that we need to assume? We need to assume about the radius and the angle subtended by the sector, right? So let the radius and the angle subtended by the arcs or arc be the following for the circle 1 and circle 2. So this is, say, circle 1 and this is circle 2. Circle 1 and circle 2, right? Okay. So what do we have? We have the radius to be x and this is y. This is A and this is B. And now the length, not the length, sorry, area of the sector formula, because that is the one which is given. So we can equate that and we can move across. Agree? So area of the sector is given by theta by 360 into pi r square. So in case of circle 1, in circle 1, what do we have? Area 1 is equal to theta, in this case is, I'm taking it as A by 360 into pi x square. And for circle 2, what do we have? In circle 2, we have area of the sector is equal to A by B by 360 into pi y square. And what can we do with this? We can do the following. We can divide them, right? Or equate them, because these two are one and the same. So we have been given that the area 1 is equal to area 2, right? Here itself I have written that. Therefore, what do we have? A by 360 into pi r1 x square is equal to B by 360 into pi y square. And now we can cancel 360, pi and pi. And so ax square is equal to by square. Okay. So this is the maximum that we can kind of solve this. We can't do much beyond this point. So we'll keep it. We'll call this as, say, 3. Now we have to talk about the length of the arc. So length of an arc is given by theta by 360 into 2 pi r. Agree? So here we have L1 is equal to x by, or a by, sorry, a by 360 into 2 pi, what is this, x. Then we have L square is equal to a by 360, b by 360, sorry, into 2 pi y. That's L2 for us. And then we have the following. Okay, what do we have? We have L1 by L2, right? 4 divided by 3 or 3 divided by 4. We'll divide them because we need to understand if they are equal or not. So that's the best way to do this is, one of the best ways is to divide them. And then we have divided by b by 360 to 2 pi y. And so we have 360, 360, 2 pi getting cancelled, and we have ay getting divided by ax, sorry, divided by by. But we have ax square is equal to by square. Okay. So I'll do something which might be a bit weird for you guys. I'll multiply with 1. That's not too weird. That's okay, right? Now, can I write this 1 as, x by y into y by x? Can I write that? Have a look. Okay. So what do we have? We have ax into x by y, sorry, by, ax by by into x by y into y by x. Why is that I'm writing this? See, ax into x is x square. Okay, that's 2, right? Not that. So we have ax square by by square. How? Taking this particular multiplication of numerator and denominator, and we left out with x and y, xy. This is something that we can cancel as per equation 3. And so we left out with L1 by L2 is clearly not equal to each other. L1 is clearly not equal to L2. It will be equal only if y and x are one and the same. So what's the question? Is it necessary that the corresponding arc lengths are equal? No, it need not be necessary. So the conclusion is the arc lengths need not be equal, and that is our answer. Again, remember, it carries half a mark, this statement.